And hello, welcome to the .NET Community Standup. So I'm John Galloway. I'm a PM on the .NET Community team, and today we have with us Brady Gaster. Welcome, Brady.
Come on.
Good. It is that magical in-between time. I heard someone on Twitter call it the limbo. It's after Thanksgiving. It's before, it's before the December thing. It's just basically everyone's gone until January.
Yep.
And it's that wonderful time where you can go through and do the things you actually wanted to do during the year. So
yeah, it's like all the things on your to-do list that were marked as like backlog or creative time or whatever, hack time. Those things are actually getting done now. It's kind of fun.
So today we're going to be talking about Orleans. And does that kind of fall into that a little bit for you? Is that something where you've wanted some more kind of focus time, or have you been working with Orleans a lot this year?
This year, Ruben and Benjamin and the folks who work on Orleans, I guess it's Ruben and Benjamin and not me, they kind of came over to the team, the ASP.NET team, the .NET team, and we sort of, I don't want to say adopted Orleans, like we'd always been a big fan of it. Good friends there. Hey, Kevin. We'd always been a big fan of it, but it had never been like, in the equation, if you will.
Yeah.
And once we brought it in, I started talking to customers, both customers who were just getting started with Orleans. So if you're one of those and you want to like talk to me and tell me what your experience is like, or you want to sit with me for an hour or 2 hours and just do some hacking, I'm totally into that. Believe me, I've been doing a lot of it myself. And then we have these new services like the Azure Container Apps service, which is going to be great for Orleans. And we really want to start investigating opportunities there. So over the past months, I've been talking to customers, like I said, the new customers who are just getting started with it, just getting started with the docs the team has written, and also talking to big customers, like a lot of big customers that actually use Orleans. I don't want to out anybody right now, but let's say you're a big game, or Orleans is a really great use case for very, very large scale games with lots of players and lots of objects in the games, because those objects can be represented with what you'll hear about later is essentially a Orleans virtual actor is called a grain. So we'll talk about grains later. But you've probably had Ruben on the show, and I was looking forward to kind of doing one myself because Ruben might pop in as well. Ruben goes really deep and he talks about the topology of Orleans and the virtual actor model. And Ruben's a heck of a lot smarter than me. And I just kind of stumbled into Orleans this year and started talking to these customers that are doing amazing things with it. Just you're talking like 2 to 3 million objects in memory at all times, running across 9 regions. Hundreds of thousands of machines, pumping objects around. It becomes very powerful, and it's been fun to like think about it from the perspective of a web developer, and think, how would I use this, and try to come up with ways to show it off. So that's been kind of fun.
Honestly, I think that's perfect, because I think a lot of Orleans presentations I've seen, they go deep really fast. Mm-hmm. And they talk about Orleans specifically. And mm-hmm. I'm really interested. That's actually, I titled the show like Scaling ASP.NET Core Apps with Orleans, because the demo you showed me seems interesting. And I'd love to just kind of get like, hey, I'm an ASP.NET dev. What's this Orleans thing?
Right. Exactly.
Cool. Before we dive in, as always, we're going to go through the community links. So we've got some cool community links going on. I'm going to send them out in the chat so you can go through them at your leisure. And let's switch over to my screen. There we go. So here's our list of links, and not a whole bunch right now. It's kind of quiet, but some good stuff. Let me see. So first of all, nice roll-up post from Jeremy Lickness about EF Core 6. Tons of stuff in this release. What's cool, I love the format of this post. It's kind of a like, here's what you need to know, mm-hmm. So it's docs and videos and deep dive stuff. So Cosmos DB is a big thing. Support for compiled models. So and specifically calling out things like distributed apps and Azure functions, and just getting that fast startup time by pre-compiling your models. So, mm-hmm. Configuring conventions. So this is setting up conventions that you would reuse across your entire application. Migration bundles. This seems really, really cool. Honestly, this one slipped by me. I hadn't even seen much about this. There is a workflow where you can, I may be getting close and away from my mic, so I'll try and stay a constant distance from it.
You sound good for me.
Okay. There is a workflow with migrations where you can, as you're developing, you're just make some changes, add migrations, update database, blah, 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 blah. But it gets a little trickier when you're actually, like in production. You actually have something that's actually running, and you want to more closely manage how those migrations execute. Mm-hmm. And there are some open source systems out there. There's some different, migration systems that people use. This is nice to see EF directly kind of addressing that more. And then performance and temporal tables. This is something that temporal tables have been since I think SQL Server 2016. So adding that support, and GraphQL, and then here's all the packages. What's that?
That's my favorite part of this blog post. Jeremy's doing some amazingly exciting stuff with the GraphQL community, and I would just continue to watch what he's doing there. Like John said, I use a little bit of my December every year to do one of Jeremy's projects from the previous year.
That's a great idea.
These great projects every end of year, and I like last year it was like the like a choose your own adventure story. He did with durable functions. I was like, I have to play with this. So this is what I would encourage everybody to look at this year. Some GraphQL stuff. It's really fun stuff. So.
I really like this model. And when I talked to Jeremy at one point, I said like, hey, and I'm sure Jeremy's got tons of great information coming in and stuff, but I really liked what you showed me about how the Swagger integration, the Open API integration with ASP.NET Core kind of works smoothly with NSWAG and Swashbuckle. I'm like, just check out what they're doing. I think I may have even sent him to talk to you, but like the whole way that they're doing GraphQL in partnership with existing great open source projects, I just love that kind of model. So,
right.
Good stuff. All right, moving on. Andrew Locke, superstar, blogging superstar, going through his his 12-part thing on exploring .NET 6. And here he's looking at a really kind of useful thing, which is how do you update a .NET 5 application to .NET 6? Because we've changed around the program CS and startup CS, and how do we kind of integrate that together? And, what is all my code? Where does my code in my startup go, et cetera? So great options that he calls out here. One is do nothing. Like, you don't need to change around your program in startup. It's all kind of built on the same kind of hosting intrinsics underneath, and you can just update your app to run on .NET 6. So that is the thing. Option 2, reuse your startup class. And so here it kind of looks at, here's the general structure of startup CS. And then so you can actually just, in your builder, you can use it to call into your startup class. So, and then option 3 here is, kind of like, if you're starting with a new application, this is kind of a way of structuring your app, is to create those local methods and kind of put that startup stuff into your program CS. And I think we're definitely going to see, I don't know if you've looked at this much, Brady, but the whole kind of like the grow up story for the kind of simplified pattern, it's like, I love that it's simpler. I love that it's not a huge bunch of files and confusing stuff, but I also don't want it to be like a 2,000 line long program CS, right?
Right.
So
I have done quite a bit of that. You'll see some of the code that I'll show today. I'm going a little nuts with it. In fact, Glenn's always taught me write middleware. So I actually really like it. This kind of makes me think differently about it. In a meeting with Ruben the other day, you'll see in one of the samples that I'm actually passing, I've got an extension method and I'm passing the I configuration to it. And of course, Ruben and I are like, how can we mitigate having to pass I configuration? And it's like, now you want to rewire everything, it starts to compress. So
yeah. I think we'll probably come out with some, there's going to be some patterns that emerge from the community. I think there's going to be some guidance. We're definitely kind of, I've talked to several people that are kind of thinking about how to, like, you want a smooth, like, we've got a good model for very simple apps. We've got a good model for very complex apps. And then how do you move smoothly between them? Right. So
I'm kind of curious if, like, folks who've always, I'll pick on my boss, folks who've always, done the right thing by Glenn and like written that middleware and written those extension methods to wire everything up and like do all your stuff, properly, if you will, rather than just services and like wire everything up. I'm kind of curious if folks who've done it that way, if they're having less pain moving to this top level approach, or if it's like harder. Just kind of wondering if, people are like adjusting to it more easily. I found that I had a lot easier time adjusting to it, having adopted a write your own middleware approach to things. So.
Yeah, that's a good point. Okay, there's one other good option that Andrew points out, and I love this, which is consider extracting modules and using Carter. So we had Jonathan on the show talking about Carter, and what's really cool here is it's got a whole kind of discovery system for a module. So you can basically create different modules, and then you can extract things very easily out to that. So he's got a link over to the community stand-up. That's something actually that, I want to continue doing as we move into the new year, is have more regular, like, get some open source projects on here. We're trying to kind of get a good balance of which shows, like on .NET traditionally has been the like full open source project deep dive. And we have some others like that, but I think this was a really good case where it's like, it's a really good option to be aware of. Cool. All right. A few just templates and things that people have shared with me. So one is Damian Bowden, and this is a template that does Blazor, BFF, backend for front end, Azure AD. So the idea here is you're creating a backend for front end from a Blazor WebAssembly application, and then, as he said, this removes the tokens from the browser and uses cookies with HTTP request. So this is something where, like, every time I work with Azure AD, I have a decent amount of relearning to do or reading through. Like, and you're trying to find the template or the tutorial, whatever that matches your thing. And then it's like, oh, okay, but they're doing it using this kind of auth and I'm doing this or whatever. So it can be tricky to get that fit. So this is a really nice one to be aware of. For people that aren't aware of this kind of backend for front end pattern, I actually I like this post. There's several out there, but this one's kind of like, what is BFF? And so it is best friends forever, but also it's this whole, and I'm not going to go through this whole post, but it's basically describing the problems you run into when you're creating applications with a lot of clients and they're authenticating to backends. And you've got this kind of complex deal with all this. I'm scrolling down because I want to find this kind of this is what we're talking about. So we've got our clients, we've got our backends for the front ends, and then they're communicating with the API services. So anyways, I'm including that in there.
I like that. It's almost like microservice thinking applied to writing your front end and your back end together.
Yep, exactly. Okay, just shout out to the Full Stack Hero team. This is the .NET 6 Web API boilerplate, and this is another kind of template. This is a pretty, so this is cool. This is .NET 6 support in 005 RC and a lot of new features in there. And what's cool to see too is a lot of community, community chipping in here. So there's a whole kind of quick start guide. What's nice with this, there's a thing in here where it talks about what all it does. So when you're creating a project, you can do file new project and you can start pulling in all the different packages and you can read all the things of how to wire it all up. Sometimes it's nice to get something where somebody has kind of built put all the parts together for you and you can at least see how you like it and which ones work for you. So this has things like, opinionated architecture, has Dapper, Serilog, has API versioning, auditing, different things like that, and support for Hangfire, different stuff. So cool. Congrats to the team on that. All right, just a few left. Christian Heilman tweeted about this new feature. This is in the latest release of Edge. You can do open, from browser tools, you can open individual Studio Code. So I very frequently will be in the browser tools. I'll be going through and tweaking things, and then I'll be copying my CSS back over into my actual source code. What's neat with this is you can actually create a workspace and open directly. You can synchronize that workspace between VS Code and your browser tools. So they've been doing a lot of work with kind of synchronization and working with VS Code and browser tools together. So some really neat stuff there. So anyhow. And last one here, just to plug, we're doing this Learn Live Modern Web Development with .NET 6 series. And so we've got a team, the team that I work with has been doing these regular shows. I just did one yesterday, creating a web API. James Montemagno and I walked through this, but these are hour-and-a-half shows, and just live Q&A and lots of coding mistakes, and we'll just do it on the fly and figure it out. But we're going through these Learn modules. So it's a great place to learn new stuff. And I am done. All right, Brady. So Orleans, what the heck are we talking about?
Sweet. Well, I did what any good PM would do, and I came with a deck.
All right.
So if you can pop that up there.
There we go.
So I'm going to borrow some slides from a recent presentation that we did internally. No secrets, I promise. With our fantastic friend, Maria. In which we were talking to some folks in our leadership about the progress we've been making on minimal API, as well as on Orleans. And I'll vacillate between my southern pronunciation, Orleans, and the proper pronunciation, Orleans. I'll just go back and forth. So just just keep everybody on their toes. So we got to talking about it, and when we started to chat with customers, especially customers who, like John and I, we know what a controller is, what a view is, we've been doing this stuff forever. It was one of those things where, they kind of wanted to understand, how it fits into their puzzle pieces. And as we started to talk to the customers more and more, we started to see that this was kind of the best way to think about, if you're thinking about, Orleans from the perspective of an ASP.NET developer, this really kind of stuck with a lot of the folks that we spoke with. And we talked to people who were, architects. We talked to people who were devs, a bunch of different PMs that we spoke with, as well as some of the folks who were, like I mentioned earlier, already have pretty high compute apps deployed either on or off of Azure using Orleans. And really what we found was that when folks kind of adopted this mentality, if you think about a grain as, almost like the stateful request response, it's that thing that lives in, some backend server somewhere, what we call a silo. You put a grain in the silo, get it. If you're a farmer, you get it. And essentially, like you would run a controller on a server, the silo becomes the server for, those grains. If you think about the stuff that, Fowler and the team have done with, Bedrock and the ASP.NET underpinning in Kestrel, it really hosts all of those things. It can host controllers, it can host views, it can host my favorite thing, SignalR hubs. And then my new favorite thing, Orleans grains. So what does it look like to host an Orleans grain? I'm going to go ahead and go to the next slide here. We can go back and forth on this. So you'll see there that we've got the front end on the left side, and then we've got kind of our storage, which, I typically use Azure storage when I'm doing stuff with Orleans. And in the middle, you've got what we call the Orleans cluster. Now that could be a Kubernetes cluster, or it could be, a series of other compute. A lot of people run Orleans on virtual machines. As you'll see me do in a little while, you can actually run Orleans on top of Azure Web Apps or on top of Azure Container Apps. The last one I don't have quite running yet because I was took a bit of a daunting example. I'll back it off and do something simpler in the future. But essentially, you've got a model, essentially a virtual actor, or a grain for all these different pieces of functionality. So you might have a grain for a player, you might have a grain for a monster, you might have a grain for a rock. You know what I'm saying? And what those end up looking like is all of these things live inside the cluster. You might have one for each individual user, as I've got a sample of here, or one for each individual language, as you'll see in a sample that we do in just a few minutes. The machine part really doesn't matter because, as you'll see in a little while, those grains can live on any of these individual silos or these servers that live inside of that cluster. And if I'm using something like Azure Container Apps where I want to, dynamically scale based on need, I might run 4 machines, or I might go up to 40 machines if I actually need that many, just depending on how much compute I might need. So there's that. I have a question from Jose Silva.
Yeah.
Do Orleans integrate well with Dapper, or do both have similar functionality? That's a great question. We are actively, the Orleans folks and the Dapper folks have already had like a series of meetings. We like to think of Orleans as a thing that's been around and started kind of in the alt.NET community and grew up a lot. Actually started in Microsoft research. And Ruben has a ton of talks about the history of it and different ways that it's been used. But it started as a Microsoft research project and was primarily in the .NET ecosystem. It's pretty much only been in the .NET ecosystem, whereas Dapper kind of grew out of the open source ecosystem with other languages and has a lot of support for other languages as well. Both have an actor model, and both have this concept of kind of abstracting away the persistence layer. Dapper supports a bit more of the a bit higher number of persistence layers than Orleans does out of the box. Orleans can support anything the ADO can support. It can also support Azure Storage and a bunch of other things. It's all in the Orleans documentation. Whereas Dapper kind of abstracts all that away through almost like a sidecar implementation and like an API set. Like I said earlier, we're talking to the Dapper folks. We've got a couple different persistence providers for Orleans. We've got, like I said, storage and ADO. One of the things we've kind of flirted with the idea of is maybe like writing a Dapper persistence provider. So if you're using Dapper and you want to use Orleans and just sit on top of it, you could do that. None of that stuff's etched in stone. It's all ideas that we're talking about, but the two teams are definitely collaborating. There is some crossover, and we're really trying to make sure we kind of position Orleans, at least for now, as something that, if you're writing .NET code, it's kind of how you want to distribute your .NET processing out, or do asynchronous processing.
Okay. One acronym, you said ADO several times.
ADO, actual old school ADO, active
Oh,
data
wow.
objects. Yeah, active data objects. So
Okay.
so like SQL, like anything you can connect an ADO DB connection to, you can put as a database for Orleans. So
Okay.
yeah. You'll see that in the docs. And then the next, and I believe final slide that the PM brought is kind of how we, like I said earlier, when we were doing this presentation, we were really looking at minimal APIs and Orleans at the same time, kind of an hour-long meeting. And what we decided to do, what Ruben decided to do, was to kind of put these two things together in like one slide demo. If you really think about it from the top to the bottom, at the very top, we have to bring in those Orleans and Orleans hosting namespaces. And then what that brings in is that use the Orleans extension method that hangs off of the host. And at that point, we're just using localhost clustering, because this is probably me just getting started deving. There's a concept called a grain factory. And the idea of a grain factory is it's essentially a pipe back to that cluster where you can say, give me a grain. You can give it a GUID as an identifier, or as a string as an identifier, and it will basically give you back one instance of that grain based on the ID that you ask it for. This will all be better when we visualize it with a demo. Then I would essentially make calls to that grain. Those are going to be RPC calls back to wherever those grains are running in the cluster. So remember we talked about that screenshot earlier, where we looked at how there's a bunch of different silos running inside the cluster. Your object could be running on machine A, machine B, or machine 423. The problem is, or the scenario is, you're just calling the cluster, and the cluster is finding that object and giving it back to you, and you can make a call to it. And then what a grain looks like, you would basically inherit from iGrain with string key. We've also got GUID key or other types of keys. And then you would implement that grain in a class. You can see here like a small little hit counter example. And then you just wire up the line above where you do use Orleans. At that point, it would literally find all those grains and put them in the cluster, and you're off and running. And that's basically all the wire up you have to do. And for those of you who, showing my age a little bit here, if you ever did like COM or DCOM, and you know what I mean when I talk about watching the Microsoft Transaction Server ball spin, when you watch the object spin, if you think about Orleans kind of like that, I know that's a horrible, topological example. But when you start to look at like the Orleans dashboard, which we'll see in a minute, it sort of reminded me of that, kind of context. You've got this place, you put all the objects in the place, you call the objects, and they scale out magically. And it's really thinking about scale out in the context of the objects versus the hosting layer of those objects. So like, rather than think about having your website in 4 different places, you think about having 14 different instances of your grain object to service requests. So
okay.
Probably better to look at a demo. What do you think?
I think so. Although I do really appreciate this. It's all on one slide. This is really nice. And this kind of like brings up why it's kind of nice to have this sort of lightweight model now, right? This is actual like real code that you could run.
Yeah, exactly.
On 27 lines of code.
Right. And if you think about, I think one of the things that's that can obfuscate the complexity of these large apps is, if you think about YARP's purpose in the world. YARP is just another proxy. You put it in front. You might have 1 to 100 different containers in the back. If all those containers are sharing load and doing some, back-end processing, how are they going to collaborate? Well, they might all be in an Orleans, cluster together, or they might all be clients of an Orleans cluster, using objects that are inside of that cluster. So,
okay.
So yeah, let me go to my screen if I can do that.
Oh, I will do that. I'm the screen switcher.
Oh, the screen switcher. Okay. I guess I have 1 other or 2 other community links, just because I want to thank these folks. Thorsten Hans wrote this great blog post on how to deploy Azure Container Apps with Bicep. I'll get that link to John over in the back channel here. Send that back to John. So that's Thorsten's blog. And this was a very helpful blog for me with like looking at the Bicep templates that you need to write to be able to deploy to ACA. It's kind of a new service in Azure. I'm just getting started with it. And Jeff Holland was nice enough to answer some of my pings over the holiday weekend as well. So I want to thank him because I'd never really done anything with ACA. So I want to recommend everybody take a look at this if you're like looking at doing microservices on top of Azure Container Apps. This is a really great set of templates to get started with. And then I also want to thank Christian, who did a really great sample using let me zoom in a little bit. My bad. He did a great sample, and I believe there's a blog post along with it on how to wire up a pretty simple Orleans scenario inside of Azure Container Apps as well. I would love it if he's watching, if he would put his env file or a sample, obviously we don't want his storage connection string, but a sample env file, so we kind of see what like all the environment variables that he had to weed through his code a bit and get some inspiration from it. But definitely want to thank these two for their work on these blog posts, and I'll share that with you as well, John. So folks who want to start looking at Orleans on container apps aren't blocked by me having not quite figured it out yet. But with all that said, I want to go over to this desktop over here. And I'm sorry, let me get rid of my kitty terminal there. So what you'll see is I have on the left, I have an app I call Translator. And on the right, I have the dashboard. It's essentially the Orleans dashboard, which is an open source project from the Orleans community. I can't, since I've gone to the different desktop, I want to make sure that's what you see here, right?
I do see both of those, and for like, so we can see them both. They're both pretty tiny type. So if you need to show anything, you'll need to zoom in.
I can zoom in a little bit. And I'll zoom in on this one as well. This one will get interesting once we start making calls to it.
Yeah.
And these are live. Anybody can hit them. Feel free. It would actually get interesting to start watching what happens over here. So what I'm going to do here is I'll show you the code here in a minute. But think about it from this perspective. I've got this web app. And what I want to do inside of this web app and this dashboard are both running inside of my Orleans cluster. And you'll see here that I have two active silos. If I were to click on those and look into one of them, you'll see one of them might be labeled web server. Here we go, translator web. And then the other one might be labeled like the backend or something like that. There's the dashboard. So you'll see these running. And this looks like it's doing a lot of activity because I've actually left on all of the dashboard grains. So the dashboard is actually run by Orleans grains. So what I'll do here is I'll go into the preferences and I'm just going to turn those off just because I want to see only my grains. So now you'll see I've only got one activation, and it's probably this, what I call this server. And we'll look at the code here in a minute. But essentially I have two types of grains. One of them is a translation server, and then the other one is obviously a translator. And you'll see here that I've only got one activation, and it's that cognitive services translation server. And I'm actually using cognitive services on the back end to go out and do a translation for an individual language. But what I don't want to do is have to loop through 103 languages, because that would take a lot of time. It would also be a lot of processing power because, I'd have to do one, then do the next request, and do the next request. So what I'm going to do is I'm going to fan that out using Orleans. So you'll see here as I start to activate these, it's going ahead, it's making a call out to whatever that the Cognitive Services API is. And I'm just going to add a whole bunch of them. And you can feel free out there as well to add and deactivate.
So I don't think we can see the link big enough. So
can't see what?
Is it translator?
Yeah, I'll drop it into you. Sorry.
Okay.
Private chat. There you go.
I didn't have the UI.
Sorry about that.
All right.
I used SignalR demo naming speak. Sorry. So if I were to actually take a bigger blob of text here and paste this in, and I'll go back over here to the overview and look at the chart. So you can actually start to see the requests come in. If I drop that in, and now you'll see how fast it actually went. And for each one of these, it was going to go out and make a different HTTP call. That is indeed a truism. But instead of me having to loop through all of them, I'm fanning out and making all those calls at one time. And now you'll see as people are starting to maybe make some calls to it, we're starting to see that maybe the latency is going to go up because they're making more calls. We're doing more outbound HTTP calls to that cognitive services back end. But now you can see really what's happening is we're starting to create more of these objects. And if I were to flip over here, now you see here we've got 56, 58 different languages getting activated. People are using the app in live. If I were to flip over here to the translator list, I'll look here, you'll see here, if I look at these silos, this first one might be the web server. The second one might be the dashboard. And you'll see that Orleans is randomly placing those translators on those silos as needed. you can control that using some of the grain placement capability that you've got inside of Orleans, which again is in the docs. Like I could say, I only want to put translators over here, or I only want to put the server over here. I could do, that kind of control if I wanted to. And then you can write your own custom controls if you want to. So.
Wow. Okay. So whenever I see demos like this, is this costing $1 million? Because it's like with that scale, how does that work?
Well, with that scale, what's actually happening here is these are just, looks like I might have done something to it. These are actually just objects that live inside the memory. Oh, we're spiking or doing something. Great. That would happen on camera. The pricing for that one so far has not gotten too bad. Like I've run this app and I've hit it with a couple of load testers. And I think I've gotten it as high as something like a $5 estimate for the month.
Oh.
Now I haven't put it online and like saw what people could do with it, but talking about the topology of it in this particular instance, my topology, I can look at my bicep file. I can show you what that looks like. You haven't had anybody talk about bicep yet on the show. It's essentially a new, it's not JSON, not YAML. It's a new custom way to write templates for Azure. I can zoom in on it. There we go. Looking at my screen here, see if that looks all right. Essentially, I'm creating a standard instance of the Cognitive Services Translator, which is going to be a per request cost. Looks like somebody might have throttled it. Then I'm laying down, log analytics and application insights. Those again are, per request. Storage account. I'm not really storing a lot of stuff. I'm really just using that as my my clustering. What's called I'm using storage for my clustering, so that the multiple silos can talk to one another through an Azure storage account. I've got a couple of environment variables, and then I lay down a VNet. And the reason that I have to lay down a VNet, and that's not a VNet that connects back to a network, it's simply a regional VNet, so that two web apps can basically have a back end. Now, the reason that I need to do that is I need to set my VNet private ports count to higher than 2, because an Orleans cluster requires, back-end communication between those different resources.
Okay.
So at this point, I would then lay down 2 web apps. I would tell both web apps what their virtual network looks like, and they basically start communicating behind one another using that virtual network. Again, that's not a virtual network that connects to like my corporate network. That's just a virtual network inside of that region in Azure. So
okay,
yeah. So you probably want to see some of the code as well.
Sure do.
So what I'll do here is I'll go into the project, and this is really the project. It's if you look at my GitHub, you'll find it. I do not have this Orleans Azure infrastructure. This is just kind of a middleware project I'm working on to kind of make it easy for me to dial stuff in. But you'll see here that the first thing is, if I look here at the iTranslation server, looking at the screen that looks big enough, here's my translation server, and it's just iGrain with GUID key. And really all I do is I pass in GUID.empty, because I really only want one server in the one server in the silo. So whenever I would make a call to get that server, I would always pass GUID.empty. That's one of the things you'll see in the docs. That's kind of a magic string trick, but I could also use a string if I wanted to.
Yeah.
And you see that this is my grain interface. And then this is essentially just a record for me to pass back and forth in the API. And then this is the response that I would get back when I'm making calls back and forth to the translator. This is what my translator interface looks like. And I'm defaulting to English because I'm not doing what Anthony Chu does in his great example called Captioner, and interrogating what the incoming language is. If somebody wanted to submit a pull request, I'd welcome it. You could add another grain, figure out what the language is. But I'm basically taking the original phrase and the original language code, which I presume to be English. And then my actual grains are right here, the Cognitive Services Translation Server and the Cognitive Services Translator. And the server really is just keeping a list of the list of the translations languages that I've asked for. That's really just a list, because later on, whenever I toggle their status, I'm actually going to turn them on. You'll see right here, toggle the active language status. I just have a list of strings that I got back from the API. Those strings are all the different language codes. And then whenever I call translate, I'm going to iterate through all of the language codes that I have, and that's that grain factory right here. inside of my translation server grain, I'm going to make a call back to the grain factory again and say, give me the grain for Spanish, give me the grain for French, give me the grain for German. And then I'm going to use that grain to do the translation of the original string. I'm going to win all those tasks. And when they all come back, I'm going to return the list back to the caller. So essentially what I do is I create one object or I get a reference to, that object in the cluster for each one of the languages at runtime. So.
Okay. Yeah. So this was really interesting because when we got everyone pinging it, then we got a few timeout exceptions.
I'm sure.
Would you be able to have multiple of a grain type? For instance, like you've got one grain per language code. Could you say, I can have up to 10 translators per language code?
That's a great question. And that was actually what I wanted to do before our call. I didn't get these all deployed. This is what I was going to use Azure Container Apps to do. You'll see that I've also got this translation service right here. And inside of the translation services worker, I basically get 20 languages at random. So what I had planned on doing was to create 5 more web apps and deploy this code to it and basically just have these start up, or I could do them as web jobs, or I could do them as Azure Container instances and essentially create one each time. And each one would reach out, get 20 languages, and then I would have 5 or 6 of those running in memory. I'd have 6 running in memory. This is 103 languages. So then whenever you would do a call, it would fan out to one of those multiple machines. But yeah, I presumed our audience would probably bring it down if it's only running on one server.
Well, no, but I mean, like you talked about, there's major games and programs and things running with millions of objects. And so you've got to be able to kind of like dynamically scale with all of that.
Yeah, exactly.
Question, speaking of scale, Philip's asking, is there a limit to how big the state of a grain can be?
That's a great question. I do not know. I wish Ruben was able to be on the call. Essentially, you think of the grain as like the actor on top of the state and the behavior. So if we were to look at a different piece of code, let me actually look at a different one here, where I've kind of taken Ruben's example of a hit counter. And in this one, I'm actually storing data using Orleans. Let me zoom in a little bit. And in this case, I've got the same kind of thing. I just wire my host up to run in Azure because I'm going to run it on top of either ACA or web apps. In this case, I actually wired up Azure table storage because I'm going to be storing stuff. I actually want to store stuff inside of my grain. Now, if I were to open up this grain, I've got this site visitor. You'll see that in my constructor of this site, let me actually get it so you can see everything. And the constructor of my site visitor grain class, I actually have this thing called iPersistent state, and I've got a list of site visits here. And what that does is every single time the track method gets called, I'm actually setting that state. And in this case, I've just got a list and I'm just adding to it. Now that list is backed by Azure Storage. So to answer to your question, how much state can I store? It doesn't matter. It depends on how much you want to store in your Azure Storage account or in your ADO database, because the grain is really just a wrapper on top of that storage persistence layer.
Okay. How does the latency work? Because I imagine as you get more and more interacting grains and they're all working with each other, and how does that all kind of like, how do you avoid that? Like we had somebody saying like, do you get into like n squared problem and that kind of thing?
That would be a Ruben question. Okay. Now I know that there's stateful grains and there's also stateless grains. I know that you can balance them independently. For stateless grains, you're not going to have a lot of the persistence issues and a lot of that overhead. But for those that you do, the overhead with Orleans is pretty insignificant.
Okay, cool.
Yeah. I wish Ruben could have come, but.
Yeah. And I totally appreciate that. This, like you get into complex questions and stuff, and there's great docs and stuff, but this is this is really cool. Okay, yeah. Question: how do you deal with concurrency and locking? Like, what's used by default, and can you change it?
You can change it. This is all in the Orleans docs, and this is stuff that I believe Ruben's Ruben's talked about in all the recent shows that he's done. He just did a fantastic show from .NET Conf. John, you might want to get that link from the archives. He actually closed .NET Conf this year with a fantastic presentation where he does all these like lines and circle drawings, and concurrency is one of the things that he talks about in every one of those presentations. So I think he leads with that, and he talks about how Orleans can literally mitigate a lot of those problems. So I would encourage you to take a look at that talk. I can't go that deep with it. I'm still the PM fumbling around and learning what I can do and how I can break it. So,
all right, I'll get that.
And
yeah, I mean, there's a ton of supercharging your cloud applications with Orleans.
Yep. The last thing I would say is I'll share the repo after I get everything in it, but I do want to point out that this repo does have out here in it this bicep file and a little setup 1 PS1. So literally you could just clone this thing, and once you clone it, you could run setup PS1 against your Azure subscription, and it will go out and it will create all of your stuff. That way, for those of you that are worried about cost, like me, while you're out there trying this out, I can go out here and I can do this. And now I apologize, but I have to kill your demo.
Oh, this is one of the biggest pro tips for working with Azure things. Always use a resource group, especially when you're playing, and then you can just delete the resource group when you're done. Like that's after I spent way too much money on like I did a demo. This was back when we were doing webcams, and I was in like Finland and I gave a presentation, and then I got on a plane, and then like a month later I checked my Azure bill, and I'm like, oh no, I forgot to delete all those VMs, and so
yes.
Pro tip: delete.
But yeah, that one I did not scale out. I appreciate everybody for load testing it. I guess I need to go back to figure that out. We can come back on at a different time after Ruben has had a chance to make that one more optimal. But what I hope to do is to bring this back out. Follow me on Twitter. I'll bring this back out, and we'll orchestrate some sort of a massive test once I get it running on ACA with a bunch of different silos, scaled out horizontally. Then we can really see what we can do. So.
Okay. Let's look back at your. I'm trying to think. In the code,
sure,
the main kind of thing where you're fanning out and doing the. I'm wondering like how you abstract things so that you are like how much your code is like full of Orleans. You know what I mean? Like
that's right.
Do you abstract it, or is it just kind of like?
Yeah. So let's walk through what that would look like. I don't abstract it too far away, like on purpose, just for this conversation. So let's start at the Razor file. Let's just start at that layer or our component, I guess. So I'll go over here to the web page, which is where we would actually make that first call. So I'm injecting a grain factory. Now, you get that for free because this web app is running in the silo. All right. Like in a client situation, maybe we'll come back and do a different one of these where it's the web app is the client, the way Christian did his sample. But in my case, my web app is actually running inside the silo with all the grains. Another reason it probably crashed. Wink, wink, nudge, nudge. Down below, when this thing loads up, what I'm going to do is to get an instance on initialized of that translation server. And all I'm doing is I'm saying my grain factory dot get grain translation server passing GUID empty. And what that's going to do is that's going to go out to the silo. And it's going to say, give me back the translation server with the GUID of GUID empty. And it's going to go, oh, here it is. And it's going to basically go, here's a reference to it. Now you're ready to make calls. All right. The next thing I do is I say, get all the languages from that grain. Now, is this a Orleansism? At this point, it's an Orleansism because I'm getting my grain back from the silo, from the cluster, if you will. At this point, I'm really just calling a method on an interface.
Okay.
When I toggle the translator, again, I'm just calling a method on an interface because I've already got a reference to that translation grain or that translation server grain. And at this point, I can just say, get all languages again. Whenever I call the translate method, at that point, I would literally just call translate using that current phrase, which is data bound. Where's my text box? Right here. So it's really just Blazor on top. Now, the only thing Orleansy in the server-side code is this, because I have to basically wire up the silo. I have to host the silo. And this is actually Tomahawk says Blazor WebAssembly is cool. This is actually not Blazor. This is Blazor server. So this is actually Blazor server, just to be clear. We want to point that out.
Yeah, there was a question like, hey, how does this work with Blazor? Can it work with Blazor front end, etc.? Like,
I don't know the answer to that. I believe you would either have to make an HTTP call back to the server, because you really want to keep your Orleans clients inside the trust boundary.
Got it. You could do SignalR. You could have a SignalR backend then that's doing it.
You could do that, and that's a really great thing. One of my pinned chats is SignalR loves Orleans.
Ah, nice.
Because if you're in the real-time army, hashtag real-time army, Orleans is a really great thing right below that layer. If you think about Orleans as a thing just below your SignalR hubs, Orleans things happen, and then you can pop it off to the client using SignalR. It's a really great combination of things to use. But so this is your server-side stuff. This is just, I'm making a call to my grain factory. There's that. Now, my grains themselves, like we talked about earlier, there'll probably be a bit of Orleans-isms in there, because in my get all languages, not really. This is me just making a call using HTTP factory, HTTP client factory, out to cognitive services. This would be an Orleans-ism, because I'm going to be getting the language grain, or creating the language grain. And see, that's the other part that's weird, is all I do is I say get grain. If it's not there, it gets created in the silo and it gets then given back to me.
It does seem like you could, like, if you cared, you could abstract them to more of a service, and the service has the grains internally and all that.
You could. Yeah, you absolutely could. And then this one's one where I'm actually calling as well, because I got to make a call to that translator. So,
okay. So question here, and I think this is decent, kind of like to recap it. But so what problem did we solve in this demo? Like, what would you do here without Orleans, et cetera?
Without Orleans, what I would have done is my index page would have essentially had in it, it would have had a callback to a API or a SignalR hub or something like that. And instead of me being able to fan out and execute those translation processes in parallel, I would have probably had to translate them sequentially on the server, and that would have taken longer. That would have been a longer experience to the user. Also, as we saw, once we started pinging it with a lot of requests, we could bring it down. With Orleans, I would have the capability of being able to scale out those objects across that cluster and scale things either way I wanted to. I could scale the UI if I needed to, or I could scale the cluster holding all the objects. Those objects were stateless, so essentially I could have multiple copies of each of those objects inside the cluster, and that way they could, one object could service multiple requests. I could also go one step further, and instead of having one language and one server, one language grain per language and one language server, per app, I could have set it up, and was thinking of setting it up so that I had one language server per remote IP address and one translator per server per language. So now we would have a much higher count of grains in the cluster, but they would be able to service each individual IP address versus having to distribute it all out. So that's one of the benefits of Orleans, is you can be fancy in how you distribute out your processing versus having to do it all in one place.
Okay. A nice thing that Philip points out too is like games is a good use case. And what's one thing you pointed out earlier, like here you've got homogeneous kind of grains, like all your grains are translators. But if you had multiple grains where you have players and, weapons and counts and scores and, like items and all these different things, right? Then that gets more complex. And if you're able to just say like, that's all over in Orleans, you handle that for me,
Right.
I like how you described it too, as it's your stateful layer, because that's a frustrating thing to wire into applications a lot of the time with ASP.NET or with web apps, because it's stateless, and you make a request and a response, and it's like, do I really want to save this out to a database? And do I want to do all this serialization and blah, blah, blah,
Right.
So.
Exactly. I really like the point that Alexander, I hope I said that right, made. The main issue being that SignalR as a distributed service needs a backplane, to sync state. That's a fantastic point. Back in the day when I started messing around with SignalR, I wish I would have used these two together a lot earlier, because I would probably have done a lot more damage, I think. And I think Fowler agrees. Like Fowler said that, the first time he saw them used together, he was like, oh, this is great. So I think we're going to do some fun stuff here. So.
Cool. Let me see. Continuing to look through. A question from Ryan about, like, a lot of different Azure services charge by reads or writes, and how would you, like, how do you manage that from a cost perspective?
That would, again, I would really want to talk to Ruben. I wouldn't want to speak out of turn on that one. I don't know. I honestly don't know. When I've spoken to Ruben in the past, and when we've spoken to the customers that have been deploying, we see that most of the ones that we've spoken to who wanted that high throughput were choosing Azure Table Storage. That seemed to be the one that wins in terms of performance and in terms of cost. But we've also seen some of the IoT scenarios would use, I think it was like streaming and event hubs. I think they would also use that. It's a really great thing for IoT scenarios as well, because you can imagine a grain is a perfect digital twin for a device. And those messages are coming in fast. So you'd want to literally have a twin, one per. I've got another demo where we kind of emulate that when we did the top of funnel, discussions with customers, where we've got, N sensors basically feeding temperature data to a centralized place. And we did that with Project Pi, and I crashed my machine.
That is interesting, the whole digital twins thing, being able to pair. And so you're programming against like a digital representation of a device, which is really neat, right? And then you don't need, we're looking at that when we did kind of an IoT focus earlier this year, I think in September. And, like Cam showed some of this stuff in his Let's Learn event, but you can deploy .NET code onto each device, or, which is some work. Or if you have digital twins, you can just write your code against the twin, and the twin just needs to work with the device itself. Yep. So it's a little abstract to think about, but it really does simplify things quite a bit.
It does. The only other thing I wanted to pull up here, I just went out to the github.com/.net, /Orleans repo. And I want to click on samples, and I want to say, I love showing this off. Ruben and I went through with Ben from the team, and we did like this huge survey of all the samples over all the different years and versions and la 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 la. And we decided to kind of like really make this like almost like a marquee of like what Orleans can do, how you can use Orleans in your apps, cool things you can build with it, like Microsoft Adventure apps, Zork clones, a chat app, because I'm here, you gotta have a chat app. A GPS app, you gotta have a GPS app if I'm here. So all these different things. Here's another one. He made a fantastic Hambao translator app, which is really, really nifty. All these apps really go through like feature by feature by feature by scenario with Orleans, and I would encourage you to take a look at that. I'll grab that link and drop it in. That would be a great link for folks who want to get started, just kind of partying on Orleans and thinking about how they could use it. The sample that I always get lost in is Adventure. I could just walk through the code for Adventure for hours and hours and hours and get inspiration. So
very cool.
Yeah.
Let me see. I'm trying to see. There's some good kind of discussion in the chat that people talking about. So I'm not sure. Let me see. I'm getting a parsing error in my brain trying to high cardinality streams in terms of IO. I'm not sure what to.
I don't know.
I don't know. Okay, good, because I didn't know either.
I'm sorry.
Let me see. Okay, here's a random question, but this is interesting. Is there an official way to stream back huge files like a zip? And I think this is something actually in .NET 5 and .NET 6, there have been some changes recently with async streams that allow kind of this without allocating. There's and I know that I would need 5 minutes to Google this up, but I know that there are some, and I think it would be in the docs. But if anyone in the chat wants to share that out,
ping Fowler about this. We just had like this really awesome Twitter conversation about this using web API or controllers. So I bet he's going to want to do it with minimal and a cancellation token. There's a way that you can do it. I think it's new, but I would take a peek at that.
There's some different things depending on the hosting model where you can basically tell the server, here's the file. I don't want to care about it. You handle it. And it basically is going to stream directly from disk or whatever.
You couldn't stream a stream using gRPC and know when you were done streaming and then grab it and decompress it you couldn't do that. That's a James Newton King question.
Yeah.
I think we should ping James Newton King and Fowler on Twitter with that question.
Okay. Wow. Okay. So this is really interesting. I've shared out these different links. This is a nice thing to dive into. And I think, actually, if you still have your slides, I want to go back to your first slide. Now, this is neat because this is a new feature. I can change your slides. This is a new streaming feature. I think this is a good thing. The mental model for me to remember here is this kind of like the digital twin is helpful. And then that stateful request response. And then also, I feel like in terms of granularity, pardon the pun, I guess, but going from like controllers and hub, which are kind of bigger, down to a grain, which can be a tiny little thing. Like your counter had it has a count and it has a method to increment the count, and that's it.
Right. So. I mean, they can be super tiny. Like if you take a look at some of the samples that are out there, one of the ones, let me actually look at it. He's got in one of these, he's actually got a thing. And a thing could literally be like ID, name, yada yada yada. Now these are the models. So these aren't the grains as much as like these are the models that the grains kind of fly back and forth. If you were to take a step back and kind of look at like iRoom grain, you start to think it's very oopy.
Yeah.
For me, the decision gets tricky when I want to make a decision, and this is just something that I'm always thinking about and pinging Ruben. Like, do I want a grain here or do I want a model here? And he'll ask me questions. Well, do you want to act on it or do you want it to act on its own? And then you start thinking, so there's that to think about. And then when you've got one grain that will act on, in this case, most of these are, this is grain acting on objects, but he'll have some cases where one grain will act on another grain. And that's when you get into the orchestration and things can get a little wonky.
Yeah. Okay. One thing that I must have, one thing you probably covered, and I was busy looking at chat or something, but in terms of the, can I run this on like anything? Can I put it in a container? And partly what I'm thinking about is the communication backend. And you mentioned like ADO for persistence and that sort of thing. So how flexible is this in terms of like, could I run this in a Docker container, and what are my persistence options there and that sort of thing?
That's great. Yeah, I had a sample I wanted to run in a Docker container that I blew up right before the call. So my bad. You can run this in Docker containers, like Christian's sample shows, and a sample that I'll have later on in the week. So just watch my Twitter. Hopefully you'll retweet it for me. I'll have a sample out there that you could literally bicep and deploy, and actually see some grains running inside of Azure Container apps. So you can run this inside of containers. A lot of the customers that we've spoken about, both first party and third party, are doing exactly that. Orleans runs great inside of Kubernetes, because when you think about the Kubernetes built-in DNS and routing, plus the fact that Orleans gives you, service discovery for free inside of the cluster. It's pretty great. So, a Kubernetes cluster is a great place to run an Orleans cluster. So.
Okay. Interesting. Stefan asking about hosting with an Azure durable function entity.
That's an interesting amalgamation. Ruben and Fowler and the folks who worked on the durable task framework have actually had a series of conversations about some stuff we could do together. I don't know where we are with that at this time, but that's great. I'm glad you mentioned that, because those are areas where we definitely see cross-pollination possibilities. Okay. Given the fact that with if you think about the idea, now I know that the Orleans Contrib folks, there's a lot of different open source things that have been contributed by people in the community, Richard Asbury and a lot of other folks, like Christian and so forth. If you look out there, you'll find a bunch of different examples of folks being able to do that kind of thing. So, I mean, it's rife. So,
okay. Yeah. It's some interesting discussion about and I think, Philip, hopefully I'm understanding this right, but basically Orleans is your internal communication, and you're not going to expose an Orleans service anywhere. You would have some sort of layer in front of it, or you have some sort of, and then this is your kind of back end scale service.
Right. That's a great way to think about it. I thought of the MIDI SignalR idea that I'm always working on. I talked to Ruben about it. Ruben was like, Orleans would be great for that, but your device would be outside the trust boundary. And that's when I thought, oh Lord, because one of the reasons Orleans is so quick is the serialization is pretty optimized. With serialization comes security. So,
and that serialization, is there any kind of limit? Does it serialize absolutely any .NET object? Is it?
Okay. It's a binary. It's a lower level binary serialization that it's fun to listen to Ruben and Barry be in the room together.
Okay. Yeah, because I know there's the whole thing. Barry goes on and on about the binary serializer, he still has nightmares about that. And
exactly.
Very nice.
Cool.
Okay, well, great stuff. Let's go back to the one top link that people getting started with Orleans, where would you point them at?
Oh, let me get that. People getting started with Orleans. Let me see if I have it in my bookmarks here. We have a DocFX generated documentation site out here. Like a lot of the other stuff in Orleans, it tends to be it goes deep. It's very deep. When I got started, I would flip between this page and the samples, and I would literally walk through the samples and just kind of figure out how to do each individual thing that I wanted to learn how to do. I am just scratching the surface. I'm a very new Orleans user. Benjamin and Ruben and Richard and a lot of the other folks in the Orleans community are super, super deep community. They love to talk about it. There's a Getter. So if you have questions, you can go to their Getter. That's kind of where everybody talks about Orleans and asks a lot of questions. We've got a ton of great information out here. We're going to have more. We're in the process of thinking about how we would migrate these docs over to docs.microsoft.com. So that's something that we're kind of thinking about doing. Some customers have asked for that. So we're entertaining that idea, but we also want to kind of create some docs that are really more problem solution approached. And we want to nail those Azure scenarios like web apps, Azure Container Apps, et cetera, et cetera. So,
awesome. Okay, I shared that link in the chat, and I'm going to go back to just us, and I want to end with a great quote here from Kevin. I think this sums it up for me too. If Brady's excited about something, I should probably be excited about it too. So you're always finding the new things and pointing us in a good direction. So I totally appreciate it.
Well, that's the best part. Ruben and the Orleans team, that stuff is not new. It's been around for 8 or 9 years. We could have lots of conversations about stuff people are doing with it. It's a highly powerful tech. I would encourage everybody to spend a little bit of time every holiday, whatever holiday it is, doing a little hacking on it. You got a ton of samples to go party on, and feel free to send me a PR if you want to improve Translator and make sure it scales out better.
Awesome.
And thank you for helping me crash it. That was kind of one of my goals today.
That's part of the fun, right? That takes me back to the old days of scaling with the SignalR demos.
You got it. Yeah. See if we can crash this thing today. Boom.
Yep. So awesome. Okay, well, I guess we'll wrap up there. Thank you so much.
Cool. Thanks a lot, everybody. Take care.